Hello my Einsteinians friends, my name is Farid Albert, and I am very happy to continue Einstein's series about special relativity. I will now talk to you about the year 1905, a wonderful year for science. Einstein, among the 5 scientific articles that he published that advanced the world, strongly attracts my attention. Does the inertia of a body depend on its energy? Next we are going to study part 4 of Step by Step the meaning of the key terms of the equations that Einstein proposed in this wonderful year, writing about E equals mass times the speed of light squared. Today we show part 4, step-by-step explanation of Einstein's 1905 paper E equals mc squared and beyond. The final step would be the decrease in body energy, expression 6, by applying the second-order term of the Taylor series. This final step is to replace the original expression of the decrease in kinetic energy K0, K1 with the term of E squared c squared obtained from the Taylor series expansion. This step implies an approximation, and is only valid if the speed v of the body is much less than the speed of light c, since the terms of higher order have been neglected. In this case, the decrease in kinetic energy of the body can approach 1/2 times m times v squared, where m is the mass of the body. Other question. So from the theoretical framework of Einstein's special relativity and in the specific conditions that occurred in its derivation, would this expression 6 remain? Yes, in the theoretical framework of Einstein's special relativity and in the specific conditions that occurred in its derivation, the decrease in kinetic energy of the body can be reiterated as expression 6. However, it is important to note that this expression is valid only under specific conditions and that its application must be careful. Would the equivalence of mass and energy finally be expressed with expression 7? Yes, that's right. Mass-energy equivalence is expressed as m equals E c squared, where m is the mass of the object and E is its energy, including its kinetic energy. This equivalence is one of the most important results of Einstein's theory of special relativity and has been tested experimentally on many occasions. Equation E equals mc squared, what would be the limitations that physics should have to apply this postulate? While E equals mc squared is a powerful equation, it does have certain limitations related to the domains in which it can be applied, as mentioned in the previous response. To further elaborate, negligible gravitational field, the E equals mc squared equation is a product of special relativity, which is a theory formulated under the presumption that the gravitational field is negligible. When gravitational fields are significant, general relativity takes precedence. In extreme conditions, such as in the vicinity of a black hole, the equation may not yield correct results because of the significant effects of gravity. No quantum effects. Quantum mechanics is the physical theory that provides a description of the behavior of matter and light on the microscopic, quantum, scale of atoms and subatomic particles. E equals mc squared doesn't encompass quantum effects and fails to provide accurate predictions for phenomena at the quantum level, like quantum entanglement or quantum tunneling. In a million years will E equals mc squared prevail? Our understanding of the laws of physics, including the equation E equals mc squared from Einstein's theory of relativity, suggests that these laws are universal and constant throughout time and space. This equation expresses the idea that energy, E, and mass, m, are interchangeable, they are different forms of the same thing. Under the assumption that our current understanding of physics is correct, it's reasonable to expect that the equation E equals mc squared will hold true in 1 million years, just as it does now and has done in the past. However, science is always evolving. Future discoveries or technological advancements could potentially lead to revisions or refinements in our understanding of the universe's physical laws. It's conceivable that such developments could change our understanding of the relationship between mass and energy, or even reveal entirely new aspects of physics. That said, it's important to remember that such changes in scientific understanding typically don't invalidate previous theories, rather, they extend or refine them. For example, Einstein's theory of relativity didn't invalidate Newton's laws of motion, but it did provide a broader context in which Newton's laws are a special case. In summary, based on everything we currently understand about physics, it's very likely that E equals mc squared will still be a fundamental principle in a million years. What is the deeper philosophical meaning of this equation E equals mc squared? This equation, formulated by Einstein, has profoundly influenced not only physics but also our philosophical outlooks. Here are a few philosophical interpretations of the equation. Interconnection of matter and energy. The equation states that energy, E, and mass, m, are interchangeable, they are different forms of the same thing. This suggests a fundamental unity in the universe, uniting concepts that were previously thought to be entirely separate. Relativity of time and space. This equation is a key component of Einstein's theory of relativity, which revolutionized our understanding of time and space. Instead of being absolute and separate, time and space are interdependent and interwoven into a single spacetime continuum, and both can be affected by energy and mass. Potentiality of the universe. Given that the c in the equation, the speed of light, is an extremely large quantity, the equation tells us that a small amount of mass can be converted into a large amount of energy. This highlights the incredible amount of potential energy locked within the matter of our universe. Human responsibility and power. On a practical and societal level, the equation also underscores the tremendous power and responsibility humans have, as it was the basis for the development of nuclear weapons. This equation highlights both our capacity to understand the universe and our capacity to use that knowledge in ways that can be both constructive and destructive. Lastly, it's important to remember that while E equals mc squared has deep philosophical implications, it is also a precise scientific equation with practical applications in physics and technology. The philosophical interpretation of the equation does not change its scientific accuracy or its practical utility. When energy is converted into matter, do photons disappear? Photons are elementary particles of light that carry energy. According to Einstein's special theory of relativity, energy can be converted into mass, and vice versa. In certain processes, such as pair creation, a photon can indeed convert into a particle and its corresponding antiparticle. For example, a high-energy photon can transform into an electron-positron pair. The positron is the antiparticle of the electron. In this process, the original photon, as an individual particle, disappears and becomes the mass of these new particles. Corollary. While E equals mc squared is a foundational equation in understanding the universe, these limitations imply that it cannot be used in isolation to describe all physical phenomena. Comprehensive understanding often requires the integration of additional theories and principles. Or maybe there is a God who besides dice plays with our minds about the universe?